I will give a very short presentation of the project. Basically, this will be a summary of what is coming next. We have 6 pitches, and it will be about all the things that I will comment superficially here. I'm the coordinator of the project. Here we can see the partners of the project. This is a research and innovation project in H 2020, and we are in the last year of our duration. The idea of the project was to develop technologies from tier 3 to 5, which means that by beginning of next year, we will finish the project and we will be ready to go to the next level, which will be a real demonstration. We still need one step before going to the market, and we brought the technologies to be ready for the next step. So the goal of the project is to develop 3 generation systems, and by this we are meaning that we are providing heating, cooling, and electricity. And we are doing so by using electrically driven natural refrigerant heat pumps coupled with photovoltaics. And we are targeting residential buildings, and in particular, multifamily residential buildings. Our measurable targets are to achieve 80% of renewable on-site share with the concept of net zero energy building, which means we produce as much energy as we need, but we need to change 20% with the grid because we are lacking a seasonal storage. And by design, the systems we are developing and we are proposing have a low investment cost, or at least lower than a conventional equivalent system based on heat pumps, and we are aiming at cost reductions between 10 to 15%. And all this will lead to reductions on emissions up to 75%. So our target is both new and refurbished buildings. So the main difference, as you know, is new buildings, they have a higher share of domestic hot water, and all buildings that will be refurbished will have a higher share on space heating, plus a bit higher supply and temperature. And for this, we are developing 2 types of heat pumps. Propane heat pumps are targeting refurbished buildings, and CO2 heat pumps are targeting the new buildings with a large share of CO2 of domestic hot water demands. Of course, we need to also cover electricity, so we are using photovoltaics and batteries, but the project in itself, it's not about developing any hardware on this level. We are using off-the-shelf components, and we are applying them on our advanced energy management system and our model predictive control. There will be a presentation for this later on. And we apply this also in our system test, the way we test the systems with the hardware in the loop, that will be also explained later on. So 3HP is aiming to develop 2 main systems. One is what we call a dual sourcing system. Basically, it's a system to provide heating and cooling for South European climates, where that is using borehole, so ground source and air as heat sources and sinks. There will be a presentation for this, so I'm not going into the details now. Second system is what we call a solar ice slurry system. This is a system that it's mainly used in Central Europe to provide heating demands, with cooling as just an add-on feature. And it's using solar collectors as a source for the heat pump, with an ice storage as an intermediate source when there is not enough solar. There will be also a presentation for this. And all the systems are using an advanced energy management system with model predictive control, and you will also hear a presentation later on, so not going into the details. We also thought it was very important to consider acceptance. We know that unless technologies are accepted, they cannot be deployed. And we did quite some work in understanding and improving the stakeholder acceptance and identify the interest on the stakeholder needs. And there will be also a presentation later on this specific topic. And as a summary, I would like to show the key results of the project. Basically, we started to develop with materials. We developed isophobic coatings for the ice slurry system. We will explain a little bit later on this. These materials were used in what we call supercoolers, that are heat exchangers that are able to decrease the temperature of water in liquid form. And we have also developed 2 kinds of heat exchangers, dual sourcing and a tripartite gas cooler for CO2 applications for a transcritical cycle. All this is done. And these heat exchangers were then applied into natural refrigerant heat pumps. We developed 3 of them, 2 propane, 1 for the dual sourcing system, 1 for the ice slurry system. These things we developed 2 prototypes, and both are tested and finished. And the only thing that is ongoing is the CO2 test for the ice slurry system. We also developed this advanced energy management system with fault detection. This is done, and now it's being applied on the lab, on a real system. And the ongoing task now is this hardware in the loop of the complete system test, where we are testing the systems in real-like dynamic conditions. So that was the picture we could take at the beginning of the project. Unfortunately, then pandemic hit, and we have been meeting mostly online until just recently.